Section 4 is going to be similar to what we did last section, where we're going to rearrange an equation, solve for a specific variable, except that the difference is we won't solve it down to this variable equals a certain number. We're going to take an equation that maybe has multiple variables in it and see if we can solve for one variable. So let's say we have x and y in an equation. Can we solve that equation for y on one side so that we know what y is in terms of x on the other side? So basically just rearranging for one of the variables. So there are lots of different formulas that you might know or be able to tell me if you were here. So, I mean, you know the Pythagorean theorem, right? A squared plus b squared equals c squared. Or you maybe know the distance equals rate times time. Or the slope formula. Slope is y1 minus y2 over x1 minus x2. Lots of different formulas that you might know. And sometimes, if we're doing a problem that involves plugging something in a bunch, sometimes it's maybe helpful to rearrange a formula in order to solve for one variable over and over. So, like, let's say I'm going to travel some distance, and I know what my distance is going to be, and I know what my rate's going to be. And I want to see like how long that might take for different distances and rates. I may want to take and solve that equation for time so that all I have to do is plug in my distance and my rate, and that will spit out my time, rather than having to take and rearrange things every single time. So an example to follow that, let's say you're driving home on I-70, you've got 45 miles to go, and you're going 70 miles an hour. How long is it going to take to get to your exit? So the distance, so we know d equals rate times time. We know that the distance is 45 miles. We're going a rate of 70 miles an hour, and we want to know how long that's going to take. So like we just did on the last page, maybe we would use the form t equals d over r instead. And then when we plug things in, we just have that 45 over 70. And if we do 45 divided by 70, that gets us 0.643 hours. If we multiply that by 60 to get how many minutes that would be, that's going to be roughly 38.6 minutes. But again, what we're looking at here is we could take and rearrange that formula beforehand to make things maybe a little bit simpler when we plug in. Another example, what if I asked you to graph the equation 3x minus 4y equals 12? My guess is when it comes to graphing lines, you are more comfortable with slope-intercept form. That looks like y equals mx plus b. So given this equation, I would maybe expect you, or you might decide to solve for y. So you would subtract 3x from both sides, and then you would divide by that negative 4, and we would get y equals 3/4 x minus 3. And then you could graph that because you see it in slope-intercept form. You have a slope of 3/4, a y-intercept of negative 3. But it's the same equation. This is the same equation here, just rearranged in a little bit different form that makes it a little bit more useful to us. So here's one where we're just asked to solve for y. So we have the equation 4x plus 7y plus 5xy equals 0. So this one's a little tricky because in some of the other ones that we've done in the past, there's maybe usually only one y term. But in this case, we have y in two different terms. So what we will want to do is get those terms on one side by themselves. So we want to get rid of that 4x. So let's subtract 4x from both sides. So we have 7y plus 5xy equals a negative 4x. And then is there anything that we can do to get those y's into kind of just a single term? And maybe from Algebra 1, the familiar term would be to factor that out. So we're going to take and factor out that y. We divide that y out of each term and pull it to the front. So if we pull out a y from each term, 7y, when we pull out the y is just 7. And then 5xy, pull out the y and we just have 5x equal to the negative 4x. And then we want to get that y by itself. So we have y times that whole 7x plus 5x. Sorry, 7 plus 5x. So we have y times that. So to undo that multiplication, we'll just divide both sides by 7 plus 5x. Divide by 7 plus 5x. We'll move up here. So y is a negative 4x over 7 plus 5x. This last one is a little bit tricky, and I think you'll see one like this on the homework. But we have 1 over x plus 1 over y is equal to 1. On this one, I'll just give you a hint to get you started, and then I want you to try to get the rest of the way on its own. So again, we're solving for y, so we want to get the y all by itself. The first thing that we need to do is we're going to multiply the entire equation by xy, because that will get rid of the fractions. So we would send that to all three terms, and so we would have xy over x plus xy over y equals 1 xy, so just xy. We can cancel a couple things, right? We can cancel out the x and the x. We can cancel out y with y. So we end up with y plus x equals xy. Now go from there, see if you can get the y isolated. So you might need to move all of the y's to one side, factor something out, and then get the y all by itself.